Good morning. So I am Angie Jones, and I am a principal developer advocate. I'm a Java champion. I love Java. I teach free courses at Test Automation University, including a Java programming course, Selenium, WebDriver with Java, visual testing with Java, and a couple of others as well. Now, while Java is still the leading programming language, it's gotten a bad rep over the years. And some of the biggest gripes I've heard are things like Java is too verbose, meaning, yeah, we have to write a lot of code to do the most basic things. And another one that I hear is that the language was not evolving fast enough, right? So the releases of Java 7, 8, and 9 were all 3 years apart, which in development lifetime, that's, forever, right? Fortunately, the powers that be, they heard us loud and clear, and Java has gotten a much needed makeover, and now new versions of the language are being released every 6 months. And with so many new features, it can be hard to keep up. So in this talk, I want to demonstrate some of the newer features of Java and how we can take advantage of them in our code, okay? All right, so what we're going to do is we're going to look at some test code for verifying this banking page. And the specific test we'll go over today is just going to make sure that all of the accounts are listed here, okay? All right, so here is our code, and let me walk you through it. Here, we're logging into the application, and we get a handle to this accounts overview page, and this is where that table of accounts is located. Next, we get a list of the account numbers that are displayed on the page, and then we want to get the expected accounts. So this test data can change. So we actually make a call to an API to get the expected accounts, and this returns a list of deserialized account objects. So we want to make a new list, which will only contain the account numbers as strings as opposed to the entire account. We loop through the list of account objects, and we add the account number from each account into our list of expected accounts. And then finally, we compare both lists to make sure that every account for this customer is actually shown on the site. Now, this was written in Java 8. So let's go through it and see how we can modernize it using some of the latest features in Java. We'll start here with the declaration of the accounts overview page. And as you can see, we're following Java conventions, right? So we're using good names for both our class and our object. However, many times, as we see here, these two names are actually the same thing, right? So this is redundant and it makes for a lot of typing. But in version 10, Java introduced type inference for local variables. And what this means is that instead of explicitly declaring the object or variable's type, we can instead use this keyword var. And Java will infer what the type is based on what's being assigned to it. Now, this is probably my favorite new feature in Java because you know how long our class names can get, right? And so I get to eliminate a little bit. So that's great. But before you get carried away and start using var everywhere, let me explain the rules and also provide you with some tips. So this does not make Java dynamically typed language like JavaScript or Python. The type is still there, it's just inferred from the right-hand side of the statement, which means you can only use var if you're actually initializing the variable. Otherwise, Java's not going to be able to infer what its type is, okay? Also, it only works for local variables. So you can use this inside of methods, loops, decision structures, but you cannot use this for global variables, even if you are initializing them. Now, while local variable type inference can be used within the body of local constructs, it cannot be used in the headers of methods or constructors. And this is because if we think about it, whoever's calling that method needs to know the data types of the arguments to send. Okay, so those are the rules. Now let's get into some guidelines. Giving this variable name and this method name, I have no idea what the inferred data type of X would be. Yeah, Java knows, I know, right? They know what the return type of get X is, but as the reader, I can't easily tell. So this makes it a little bit difficult to work with this variable. Now, you should always use good variable names, but it's even more important if you're going to use var because you lose a bit of context. Okay. Once you start using var, you're going to love it, but don't overdo it. This doesn't make sense, right? Using var here is not going to do you any favors. Just type in. They're both 3 letters. Now, I've updated our test method to use vars, and I'm going to explain like some rationale behind some changes when I switch to var, right? So I'm using var here, and the inferred type is very clear to me as the reader because of the variable name that I chose. But here, I changed the variable name from actual accounts to actual account IDs list so that it's clear this is a list and it's holding the account ID. So you see there how I lost a little bit of context when I removed the type. For this one, I also changed the name from accounts to accounts list so that it's very clear. This is a list holding account objects. Here, I changed the name to be more representative. And I also explicitly define the data type of the array list on the right-hand side. If I didn't use this diamond operator to indicate that this is a list of strings, then it would be inferred as a list of objects, which is okay in this case. But if I ever needed to, access one of those elements and use the dot operator, then I wouldn't have access to methods from the string class. I would only have access to methods from the object class. Okay. And then here I'm using var inside of a for loop just to show you that it can be done. Okay, let's see what else we can modernize. How about let's go inside of this get accounts method. Now, remember, this is the table, and we're getting all of those values in the first column labeled accounts, and here's the code to do so. We see here that it finds all of the account cells, and these are web element objects. Then it creates a new list to hold just the text of the web elements. So this is a list of strings. To populate that list, we loop through each of the elements from line 3, and we get their text, and then we add them to our new list on line 6. And notice this method needs 2 lists and a loop, right? So, of course, there's a more modern approach to do this in Java by using the functional programming style. So this approach was actually added in Java 8, but I don't see it used much in test code. So I wanted to highlight it to say, you don't have to just use this in your production code. Use it in your test code too, all right? So this is much more streamlined. Here we still call find elements to get the list of web elements, but we don't need to store them. Instead, we turn them into a stream from which we can do some cool functional programming, right? So this map function will take those web elements, map them into whatever is passed into this. So here we're saying get the text from these web elements and store them into a list, which we return. All right. So here's an alternative way to write that map call. And notice in the top example, line 5 uses a shortcut or a syntactic sugar with the colon, but in the bottom example, line 3 uses the fully spelled out approach with the lambda arrow. We can do the same in our test method. So instead of using the 2 lists in a for loop, here I changed it to use a stream and map what I need into a single list. All right, so it's a good practice to break up these chain method calls where each method call is on a new line. And it's really tempting to do this big, powerful call, all on one line because it's like, wow, look at this wicked one-liner that I wrote, It makes us feel good as programmers for some reason. But it makes it harder to read your code and process what it's actually doing. So it's a good practice to break it up so that each call is on a new line. All right, let's look at what's new with streams. So Java 9 introduces a couple of new methods to stream, one being take while. Let's say I have this code which gets the list of accounts, and then it uses the take while method on this stream of accounts. Within this take while method, you pass in a condition, also known as a predicate, and this is saying to go through this list of accounts and accept all of the ones that have a type of checking until you get to one that does not have this type. So here are all of the accounts stored in accounts list, and notice there are 11 of them. And when we say take while type is checking, we end up with a list of 3 accounts. And as you can see, it's the first 3 accounts from the accounts list, even though there are more that meet this criteria, right? But when it got to that 4th account, because the type was savings, not checking, the stream is ended. So it doesn't get the rest that are below that. Java 9 also introduced drop while, which does the opposite of take while. So for this one, we're saying drop the accounts of type checking until you get to one that is not. So with 11 accounts here, we see the first 3 are checking, 4th is savings, 5th through 9th are checking, and 10th one is savings, and the last one is checking. So how many accounts do you think will be collected here in checking accounts list? Do, 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 do. If you said 8, you're correct. Good job. So this method dropped the first 3 accounts because they matched the predicate, and then it stopped the stream once it got to one that didn't, okay? So then all other accounts are collected and stored into the list. All of those accounts couldn't fit on the last slide, so here's the rest of them. This is the full list of drop while account type is checking. So you might be thinking, Angie, why on earth do I want to use take while or drop while, right? The examples that I showed you were a bit of a brain tease because the lists weren't sorted, so the results were indeterministic. However, if you sort the collection first, as we're doing here, it makes a lot more sense. And notice I'm using this comparator to specify which property I want this object sorted by. Okay, given the sorted list, we see now it collects all of the checking accounts, and this actually makes more sense, and likewise for drop while. All right, so let's see what else we can modernize. How about we go inside of this get customer ID method? So this method is holding our test data, and based on the name on the account, it's returning the account ID. Now, this is using switch statements. Notice that we have to declare the variable, then specify each case we want to handle. And inside of the case, we assign the value to ID, and then we must follow the assignment by a break statement to prevent fall through into the next case, which would override the variable. So not only is this a lot of boilerplate code, it's also risky, right? If you forget one of those break statements, and we've all been there, this will return the wrong ID. In Java 12, switch expressions were introduced. Now you can use switch to directly assign a value to a variable. So notice here, we're using switch on the right side of a statement to initialize this variable. And the case statement doesn't need a colon and switch expressions, but instead it uses an arrow. And this is saying if the name is John, then assign 12212 to the variable ID. Notice, I don't need a break statement because there is no fall through with switch expressions. And I can even simplify this a bit more by removing the assignment here and simply returning the value of or the result of the switch expression, okay? Now, using the lambda style arrows is one way to assign the value, but you can also use another approach. You can use the colon that we're used to, but you need to follow that with the word yield. This is a bit more verbose, so I actually prefer to use the arrow, but I'll show you a little bit later where yield really comes into play. You can also specify more than one case. So notice here, we are saying if the customer name is John or Demo, which is his last name, then the ID is 12212. And this makes up for the removal of fall through from switch expressions because you can indicate all the cases delimited by a comma. And you can also do more than just assign values. For example, here we're using the lambda style arrow followed by a set of curly braces to indicate that there's a block of code we want to execute here, right? So instead, inside of this body, we add more statements like this one that prints something out, but then that last line, and this is where the yield comes back into play, that last line must yield the value to be returned because that's what switch expressions are all about, right? Okay, let's talk about the rules. So you'll need to use the arrows or the colon yield. You can't mix and match this. So line 3 would give you a compilation error because it's a different kind of case. You can use yields with the arrows, but only in the events like I just showed you where you were using the curly braces to execute multiple statements within a case. And you can use any of the cases to throw an exception. So of course, in the default case here, no value is going to be returned because the entire flow is interrupted by the exception, and it's not limited to the default case. So you can throw an exception from any of these cases, different exceptions, same exception, doesn't matter, okay? This is not a replacement of the switch statement. It's an addition to the language. So what this means is you can still use switch statements, and in some cases, that might be the more favorable option. As a rule of thumb, use expressions when you're using switch to assign a value, and use statements when you're not using switch to assign values, but to invoke statements. All right. Okay, let's go back to our test. So we're going to go inside of this get accounts method, which is an API call. So this method is making a get call to get all of the accounts for the specified customer, and it's then deserializing the response into an array of account objects. So let's look at the API response for this call. Notice here we have an array of these account objects, and each account has an ID, customer ID, type, and balance. So I have this Pojo class that has nothing but these fields as well as getters and setters, right? And for any of you who have created Pojos, you know that this is a tedious thing to do. It's not your favorite task of the day, right? Many people have moved to using Lombok external libraries so that they don't have to write all of this boilerplate code. But great news, in Java 14, a new construct was introduced called records. So this is a record, much shorter, right? And notice here, instead of using the word class, we use the word record. Also, as opposed to opening this with a curly brace, we use parentheses to declare the fields. So you specify the fields and their data types in this comma delimited list, and then you close it with a closing paren and a set of curly braces. And that's it. You don't need to make any getters or setters. You don't need to override the inherited methods of equals and hash code and toString. All of that is just done for you. However, if you just want to override anything or, add stuff, you can do so within that set of curly braces. So you can add whatever you want inside of here, okay? Records can be instantiated just like classes. So account is the name of our record. We use the new keyword and we call the constructor, passing in the values, just like we would do with a normal class. The fields of a record are final, however. So there are no set methods generated for records. And of course, you can add a setter within the curly braces of the record, but I don't see a good reason to do that since the fields are final and they can't be modified anyway, right? If you just really needed to hack something, I guess you could find a way, but yeah, remember that those fields are final. You do have accessor methods. However, they don't start with the word get. Instead, the accessor method name is the same name as the field name. So notice here, we're saying account.balance versus account.getBalance, okay? Records were released in Java 14 as a preview feature, and that was in March. And what that means is that it's not yet a permanent feature of the language. It's just available for us developers to play around with, offer feedback. Based on that feedback, the implementation can change. So don't use records in production code just yet, okay? It also means that support from external libraries might not be readily available. For example, I used the Jackson library to deserialize that JSON response into this record, but when I tried this, when Java 14 first came out, the Jackson library didn't have official support for records yet. So as a hack, I needed to explicitly bind each field to its respective JSON property. When and if records becomes permanent, I already know Jackson is going to provide support if they haven't already. I saw a few tweets that they were working on it, so good to go. Next, I want to show you text blocks. So we're going to continue on with the API. What if instead of calling the API, we instead wanted to mock the data right there in this API util class? To represent this whole thing as a string would be pretty tedious, right? We need to escape all of the fields because they are already in quotation marks. We need to add new line characters for each line break, and we need to add the plus sign for each line. So this is ugly. It's ugly to read. It's ugly to write. Text blocks. They allow you to use 3 quotation marks to open and close a big block of text. Notice you didn't need to escape anything, right? The individual quotation marks are still there on the fields and the line breaks are respected. Now, text blocks were introduced in Java 13 as a preview feature. We got another preview in Java 14. And I'm happy to announce that text blocks have become a permanent feature in the latest release, Java 15, which came out in September. So yay, welcome to Java text blocks. We're so glad you're here. Okay, let's look at some of the rules and guidelines around text blocks. You cannot include the entire text block on the same line, or you're going to get a compilation error. So a new line must be after the opening quotes, like in the second example here. This is legal, but not the preferred way. Looks a little, imbalanced. The preferred way is to have both the opening and the closing quotes aligned with the text in the middle, right? And I'm showing you this small amount of text because I needed to fit it on a slide, but don't put like a single line of text in a text box. Use your strings. If you have a big blocks, that's what text blocks are for, okay? One more thing I'm going to show you in that API class. Let's say we didn't want the entire response, but we wanted to just return a hard-coded list of expected account IDs. The old way of doing this would be to use the arrays.asList method. However, in Java 9, this of method was introduced for all entities in the collection framework. So lists, maps, sets, all the jazz. This one seems small, but I've actually been enjoying it. And I think the reason for that is because it's more natural for me, right? Before it took like this small cognitive effort to recall which class do I use to make a quick list? Is it array? Is it arrays, plural? Like what is it? But now I want a list, I call list.of. I want a map, I call map.of. Nice and straightforward. And speaking of maps, populating these required a separate method call for each item that we wanted to add to the collection. But now you can define a map all with one line of code. The parameters are key followed by value. And you see here, we have 3 entities added to this map in one line. Woo. One more thing to note about the use of method is that it creates collections which are immutable. What that means is that the collection cannot be changed by adding, removing, or sorting it later. So only use this when your collection won't require any changes later on in the program, okay? So there you have it. These are a few of my favorite new features from recent versions of Java. I've been using them in different projects. I find them quite useful even in test code, all right? So thank you so much. If you have any questions or anything like that, feel free to reach out to me. Here's my contact information. I live on Twitter. My DMs are open. And you can also go to my website, angiejones.tech, and reach me there.